Something allowed. But this one, we ended yesterday with 8 possible factors, plus or minus 1, plus or minus 1/2, plus or minus 3, plus or minus 3/2. Do you remember where this came from? What goes on top? Yeah, you can call it the constant term or the last term, if it's written in the right order. And what's on bottom? Factors of leading coefficient or the first term's coefficient. And remember, this is only for the possible nice zeros. Possible, we call them rational zeros. Okay. What could you do next in trying to get to the complete factorization? Okay, notes open, Lauren. The complete factorization. Lauren. Notes open. There you go. We're in 2.5, okay? All right. We have 2 options. One is plug and chug. 2 is synthetic division. What do you guys think? Straight to synthetic? Really?
Yeah.
Aww. Okay, some of my mental mathers figured out plugging in 1 isn't too bad because you get 2 plus 3 minus 8 plus 3. 3 and 3 is 6 and 2 is 8 and 8 minus 8 is 0. Why do I like plugging in if I can? It saves me work. I just found a 0, so now that I go to synthetic, what do I already know? Because the function value is the same thing as, ooh, quiz time, the remainder. So how do you find function values? I can find f of 1 by finding the remainder. And when we do synthetic, what do we do to this big old cubic? Break him down, right? So we have the 2, we have the 3. Some of you seem a little like in a daze. I know we just took a quiz, but this was an example we started yesterday. So you're in your notes, right? This was the very last thing we did yesterday. We're right after where we ended in section 2.5. This big old guy. And we're plugging and chugging. So now that I do synthetic, I go ahead and multiply, right? Add, multiply, add, multiply, add. What was the purpose of that synthetic? I already knew that 1 went in. I already knew that the remainder was going to be 0. I broke it down into a simpler good. So what kind of polynomial is this now, Matthew? A quadratic, because the degree goes down by 1. Jordan. Mm-hmm. Well, how did I get the list, or how did I choose 1 first?
No, the 1, 3, 1, 2.
Oh, factors of the last. The 3, just 1 and 3. What nice whole numbers go in?
Okay,
just 1 and 3. Mm-hmm. 6 had a lot more options.
Yeah, no, but you did it. Yeah, you did 1 and 6. Oh wait, so
1, 2, and 3, and 6. All possible factors. I only crossed these guys out because later, once I divided, then I had a 3, so I'm like, oh, factors of 3 are only 1 and 3. So I narrowed down my list for the next one. But I started with 1 and 2 and 3 and 6. Yeah.
So you're always doing just the DCF of the last term?
The different possible factors of the last term on top, and the different possible factors of the first term on bottom.
So then when you're plugging in, like, when you did like F of 1 or whatever,
I was checking the very first guy. And if he didn't work, I would have checked -1.
what's the list from? I see the 1 and the
1 over 1, 1 over 2. 3 over 1, 3 over 2. Oh, my comma got mixed in. Yeah, no, not square root. Just comma.
Okay, so you're just doing every comment.
Yeah. So then we can go ahead and say, x, why am I going to put -1 even though I put a positive 1 in the parentheses? What's the terminology, Joe? The x equals +1, good, which is the 0, so x minus 1 has to be the factor. You can also think this is a, and that's x minus a. Guys, should we be able to finish this guy off with a modified x method maybe? Okay. I'm not going to go ahead and do the entire modified x method. 6 and -1. You could go ahead and do your grouping. I'm going to do my ... since I do guess and check. And we're trying to save on time a little bit. We're going to get 2x minus 1 and x plus no. Yeah. 3, not 6. 6x minus 1 is 5x. Good. And that's our full factorization. Do I need to keep going? Should I keep going if it just says factor? No. What do the directions need to say for me to keep going to x equals numbers? Find the possible zeros. Yeah. Find the solutions or find the zeros. Exactly. Exactly. Okay, so you guys got just another quick example of what's going on as far as if you have a big old nasty polynomial, we list out the nice zeros, the possible nice zeros, and then we test. We either test by plugging in, or we test by synthetic, or we do a little bit of both. But our goal is to find ones that work. Here's a clue, though, that you might need, because we're not just stopping with reals. We're going to complex also. We're not just stopping with reals, we're going to complex also. And a quick little hint that might be very, very helpful at some points is that complex zeros always have to come in what we call conjugate pairs. They always come in twos. And maybe some of you understand why, maybe some of you don't. But if you think, complex zeros are always going to come from basically quadratic formulas where the discriminant, ooh, that's a good word from last year, where the discriminant is negative. Complex zeros always come from the quadratic formula where the discriminant is negative. And if the discriminant is negative, what comes right before that quadratic formula? A plus or minus. There's always going to be two of them, not just one. If we have a complex zero, there's always going to be two of them, not just one. How on earth could problems force you to use that clue? What if they don't give you a polynomial? What if they give you clues about a polynomial and say, hey, can you find me? How? Well, it tells me a degree of 4. So right away I know it's going to be an ax to the 4th plus bx cubed plus cx squared plus dx plus, I'll put e even though he's usually a number, but we haven't really seen him this year yet. That's my polynomial. Give me a second, Joe. Let people think, okay? But I'm glad you're thinking. Just do it quietly. ax to the 4th plus bx cubed plus cx squared. I need to find all those coefficients? Oh, by the way, they're all real. Well, great. That's okay, good. I'm not looking for imaginary numbers, at least. But wait a minute. How does this help me? Zeros, which could be turned into what? Oh. So they're telling me the polynomial? Remember, if these are a's, now it's starting to get confusing with the notation. If these are zeros, I can turn them into factors by just going x minus that number. Wait a minute, hold on, that's only a cubic. They didn't give me everybody. How many zeros should this guy have? 4. Have a little stinkers. They expected us to figure out there's also a negative 3i. So it's not just going to be x minus 3i. There's also going to be x plus 3i. How do you find the polynomial? FOIL. It's like the answer we got yesterday in our opener, but we're going backwards to the actual polynomial. Kiddos, you might want to take a picture of this slide on the way out, how to attack factoring polynomials. I want you guys to, by 7 a.m. tomorrow, as you take pictures of your homework, get as far as you possibly can. Let's say at least halfway for the picture in the morning. Sound good? Yeah. All right, get out of here. At least halfway. Get as far as you can. Some of you may be all the way. Some of you might be like, half is enough. And that's okay. Oh, yeah.
Yeah, I started it yesterday, and I had to make my own little chart.
Oh, no, I'm sorry. It's online in the helpful link somewhere, but yeah, that's okay. Sorry, Sam. There you go. Do you? Yeah.
Thank you.